All right, at the very top, we've already defined this. We're going to talk about quadrilaterals. Now, by definition, a quadrilateral is any polygon with 4 sides. Now, we've already talked about the definition of polygon. Polygon is a closed figure in a plane made up of segments. The next layer in the tree, all the definitions for this next group start off with a figure that is a quadrilateral, and ... And so that's the idea behind this hierarchy. Whatever definition, whatever parts of the definition fit above get inherited down to the children, so to speak. And there are 3 things at this level. There's the trapezoid, parallelogram, and kite. Now, there's always a bit of a fun debate about these arrows. Should the arrows point up or should they point down? And the reason that mine point up is in that same context that we use with the conditional statements. If a figure is a parallelogram, then it's a quadrilateral. If it's a kite, then it's quadrilateral. Let's get some definitions up here. A trapezoid is a figure that is a quadrilateral and has only 1 pair of parallel sides. Parallelograms is a figure that's quadrilateral and has 2 pair parallel sides. And then a kite, figure that is a quadrilateral and has 2 pair of, this gets a little dicey now, consecutive congruent sides. Get that a little better centered. A trapezoid you guys probably have seen before. Those sides are parallel. Those sides are not. Parallelogram. Let's take a rectangle and give it a good hearty kick. Over it goes. There.
What do you mean by consecutive?
Flying kite. The kite looks like this. Just like a kite that you would normally picture from being a kid. These sides are congruent because they're next to each other. And these sides are congruent and they're next to each other. Now, part of the reason we're particular about that consecutive side bit is when we look at parallelograms' properties, we're going to see some interesting things happen with those lengths. Shoot.
Isn't it also parallel? And it's the parallel sides that make...
No.
So those aren't parallel?
No, those are not parallel. Because if they were parallel, well, first of all, consecutive sides can't be parallel because they would never cross. If the opposite sides are parallel, it would be a parallelogram. Yeah, I may have accidentally drawn them to be kind of parallel-ish. And that's just a mistake of the sketch. The other thing to mention is these aren't the only rules that apply to these names, but they're the definitions. These are what we use to define the figures. When we talk more about the properties of a given figure, this list will get longer, fear not. Now the next layer down, like the one above, inherits all of those names. So anything I draw below it starts off with, these are all figures that are the guy above, and I'll write down the new qualifier. And there are only 2 at this level. Specifically, we have the rectangle, which has 4 right angles and 2 pair of parallel sides and is a quadrilateral. And there's also the rhombus. It has 4 congruent sides. Now, it's kind of interesting with this by definition. If I draw any figure with 4 congruent sides, it's guaranteed to be a kite because it hits that 2 pair of consecutive sides rule. Here, I'll sketch a rhombus. Let's slide quadrilateral off. So a rhombus kind of looks like that. So there's 1 pair of consecutive sides that are congruent. Here's a 2nd pair of consecutive sides that are congruent. So that makes it a kite. And a consequence of having all those guys equal is that the opposite sides are parallel, which makes it a parallelogram. Likewise with a rectangle, if I draw any figure made up of 4 right angles, I'm guaranteed to get a parallelogram. That's just going to happen. I feel like I'm doing an infomercial here, but wait! There's more. You'll get a square. Well, now that's what's neat about the square. Here's the square. The square actually has one of the least exciting definitions in the sense of the square is literally defined as just everybody else. Yeah. If a figure is a rectangle and a rhombus, then it's a square. So 4 congruent sides and 4 right angles. I'll leave that like that just for a second. And remember, the arrows point up to show the relationship of what is in what group, mostly to address the kinds of questions and true-false statements related to if a figure is this, then it is also that. So for example, if a figure is a rectangle, then it is a parallelogram. True. If a figure is a kite, then it is a square. That goes the wrong way, so that's false. The other kind that we like to ask with this are the sometimes, always, and never. You'll see those like on the ACT. A rectangle is a kite. Well, the answer to that would be sometimes, because squares are rectangles and kites. So sometimes a rectangle is a square, which would mean it's a kite. Sometimes it's not. A trapezoid is a kite. Well, here's trapezoid. Here's kite. There's no relationship, so that would be never. Rhombuses are parallelograms. And that's always true. And so that's another way we approach how to organize these.